having introduced the exponential function and its graph in the previous video, in this video we're going to look at what happens when the base of an exponential function is a fraction between 0 and 1. So to start with, here's the function f of x is equal to 2 to the power of x, which we've seen before, and we've plotted it with x values ranging from -3 to +3 on the graph, as well as filling in the y values on the table of values. Now, we're going to do the same sort of thing when the base is a half. So if the base is a half, when x is equal to 3, then k of x here is equal to a half to the power of -3, and by exponent rules, that's equal to 2 to the power of +3, which is equal to 8. So pause the video now and take a moment to fill in a table of values like this for k of x, where k of x is equal to a half to the power of x, and plot the graph as well. So if you've done that, now you should have something that looks like this. Notice that the graph of k of x is equal to a half to the power of x is a reflection of the original f of x is equal to 2 to the power of x graph in the y-axis. It's a horizontal reflection in the y-axis. The y values here are the same as the y values here, but in the opposite order, or reversed. So if we ask how are the graphs of f of x is equal to 2 to the power of x and k of x is equal to a half to the power of x related, they are reflections of each other, horizontal reflections of each other in the y-axis. Now, we can also look at why that's true algebraically. So if k of x is equal to a half to the power of x down here, we could rewrite a half as 2 to the power of -1. So a half to the power of x becomes 2 to the -1 to the x, and by our exponent rules, when you raise a power to a power, you multiply them. So that becomes 2 to the power of -x, because -1 times x is -x. So k of x, which is a half to the power of x, can be rewritten as 2 to the power of -x. Now, what we've done here is we've replaced the original x in the function f of x is equal to 2 to the power of x. We've replaced that x with -x, which is what we do when we're trying to make a reflection in the y-axis, or horizontal reflection. In other words, k of x is equal to f of -x. So that's an algebraic way of showing what's going on when you have a fraction between 0 and 1 as your base. To summarize then, and more generally, if f of x is equal to b of x and b is greater than 1, we have this kind of exponential growth pattern. This graph is actually 2 to the power of x, but the general form will be the same for any base greater than 1. They'll all have a y-intercept of 0, 1 if they are untranslated, if we haven't shifted them up or down. As we make b bigger, the graph will get steeper, as we saw in the previous video. On the other hand, if we take the exponential function f of x is equal to b of x and give it a base between 0 and 1, we flip it around. It's reflected horizontally in the line y is equal, in the y-axis. Again, the y-intercept is the point 0, 1. But now it has this kind of exponential decay pattern as we move from the left to the right. As we move from the left to the right, it's decreasing. So when the base is greater than 1, you have exponential growth. And when the base is between 0 and 1, you have this exponential decay pattern. So that's the exponential function when the base is between 0 and 1.